We're almost ready now for the database stuff, so we can start committing all of these changes and settings to actual database. Just before that, we need to fix a few little bits, and then hopefully we can start to dive into using Entity Framework in the basics. In the last video, we realized that the new drop-down box didn't have the settings and also didn't save, so it didn't add to this list here. So we'll just quickly fix that one now. That shouldn't be too much of a problem. And that should be in, I think, the Actions page view model where we just did the last code. And here's the add new bit of code. So in here where we're just popping up a confirm dialog and doing nothing, we need to do similar to this edit dialog. So what we want to do is create the dialog here. And then really all of this code that we wrote, so we cut all that out. All of the code there is about linking the printer details into a view model. So instead, we'll make a new helper function, and we'll just call it something like inject printer details. Yeah, I think that'll do. We'll need the view model, generate the method, and place it inside here. So that's just all the code copy and pasted. We'll rename this to just view model. And then it should be as simple as calling that inject printer details in the new. So we make the new view model in a similar way, inject the details, and this will now be the confirm view model. And then let's see, we still do nothing here about adding it, but let's see if we get the printer details. We go new. There we go. So now we've got the we've got the printer details, but they're all linking together, and that is because let's see, make a new print profile. There you go, to do remove when we pull from database. So at the minute, this will call design time data on a new drop down, and that's just going to clone this over and over, so it's the exact same piece of information. So we can do a similar trick for now, which is again probably to do remove once new confirm view model dialog is pulled from database. And all we need to do is effectively restore from the JSON of it, and that'll break all the links. So we just serialize the view model and re-serialize it from the JSON. That'll break all them links. And now if we go to new dialog, yep, there we go. So that's working. And now for the save, that should be simple. We should just add at the end of here to the print list, actions print view model, printer profile view model. No, it's not print list, printer profiles. Printer profiles.add and confirm view model. Yeah, I think that's it. And then we cancel, we do nothing anyway, but now this should add to that list. We get to actions new. We probably want to pre-fill these info with new profile, test, save. There we go. So now new profiles at the bottom. Edit. Yeah, and that's saved. So that's worked. We can delete it as well. Yep. But let's just fill in the name with new print settings and description with. In fact, description can stay blank, but we'll give it a title, a default title at least. And we have technically no strict requirement for the titles to be unique because that's not the key of the database. But we could always enforce that if we ever wanted in future. When we're adding multiple ones, you could limit it to not say that. But there's a hidden key behind here when we save to the database. There's going to be an ID, so they could technically have the same names and descriptions, even though it's not that obvious. That's that bit done. The other thing I've noticed for ages is we don't actually have an icon for the app, so you always see this nasty default icon. It's fairly easy to do, but I think the reason we didn't do it is because I made the icon with an SVG, and if we try to use that in the app or main view, I think it's the main window. If we use an icon here, and we just say it's the assets images icon.svg. That is all you need to do to add an icon. The problem is this icon thing, I don't think supports SVG, so it fails to load. Plus, even if you do use just an image, it's got one size, you really want an icon. So for that, you got websites like this redketchup.io, and then icon converter. We can just upload the icon that's that. And we want the icon to produce all of these sizes. We don't necessarily need 512, we can chuck it in there for the sake. But then Windows can pick which icon scales correctly. You want it to be a square, which ours isn't quite, so that's going to fix that for us. And I think you just click download. And there's the icon. Download. And now if we just go into this folder, so open in Explorer, paste in the icon, change this to ICO, and that should hopefully get us a nice icon. Assets, images, icon.ico, can't be found. Have I not set it up as a resource maybe? Yeah, build action none. So that wants to be an Avalonia resource. Let's try that again. And there we go, we finally have that little icon that's been bugging me for a while. The title as well is defaulting, which we don't really want it like that. So this wants to just be batch process 3. And we'll just do 3.0.0, and then we'll actually tag this in with the real version number when we start doing that. So before we do the entity framework stuff, let's just make sure we haven't updated these packages in a good while. So the first thing I'm going to do is edit the projects, and .NET 10's in preview now. I'm pretty close to release, so let's just jump onto .NET 10 by editing all 3 of these projects we have. I know it's technically still not in the full release candidate, but it's close enough. I think we might as well do the upgrade now while we're doing upgrades, and then we'll get all the latest packages as well. Just close all tabs. And then after that, right click on, say, batch process, manage NuGet packages. And we want to go through all of these, right click, upgrade, right click, upgrade, and just do them all until there's no upgrades left. And hopefully nothing will fail. And the one thing to watch out for is when you're upgrading stuff, you almost always break something. That's just why I kind of like to try and do it semi-regular, so that when you're doing an upgrade, you're not bouncing too far ahead and, you know, having even more issues. Deal with them regularly with the upgrades. So I think that's that all upgraded. We will have to, well, we'll leave that one because it's not even used. We'll manage the desktop one, upgrade this. There's only 2 in that one. And that's it. Let's run the application and see if we've broken anything. It's only gone up a minor revision, 2 minor revisions, I think, so hopefully nothing's broke. Yeah, seems to be functioning still. Yeah, oh, there's the header there. Yeah, so the only thing I can see is this header, the image. See how it's cut off? It should be all the way down. So it has broken something. That's all I can see that's broken there at the minute. Let's take a look in, say, the settings page. Bring that down and see this image. That's here. So height 100, 200. Yeah, so it's obviously it shouldn't be 200, but when we're setting it to 100, it's not actually 100. That's like 15. So it's not scaling the same anymore. Remove the height. Right, so when you remove the height, it's scaled correctly. It's filled. But then what it's done is, obviously, if we're trying to limit the height of an image, it's not sort of scaling the image and cropping it. It's actually making the image width 100 and then overriding this stretch by the looks of it. So let's just try and wrap this in, I don't know what to wrap it in, maybe a panel. And put the height on the panel, maybe. Nope. Stack panel. Oh, there you go. Stack panel works. So we put the image in a stack panel. It's now scaled over, but now we just need to crop out this overflow. So that should be as simple as clip to bounds true. Yes, there you go. So now we've got back the behavior we had before. So we're going to have to copy that and paste it into actions page, is it? Yeah, actions page. So override this one, background actions, and change that to background actions. There we go, back to what we had. So that's a minor change. You'll probably find that in the change logs if you look somewhere, or maybe you don't know about it. I'm not sure whether you class that as a bug or not. It might just be the way you expect it to work. So I think we're good now to attempt some Entity Framework. And for you that don't know, Entity Framework is a way to store settings, so like usernames, passwords you normally store as hashes, not passwords. These settings here, all of these here, basically every piece of information that gets stored in your application, we'll typically store it in a database. And the way we used to do it is to directly write things like SQL statements and figure out all the queries, and it was a lot of raw code. So Entity Framework is, in short, a way to write more C# code. So if we take a look at, say, like here, we're just writing C# code. We've got a class here called the database, and it's a context. Then we add things to it, and we're adding just classes to it. And then you call in save changes. You can order, you can search. So it's much more object-oriented friendly, and there's no database code here. What you can then do is literally choose a database that you want. So Entity Framework supports multiple database types. So SQLite, there's SQLite, for example. You can see database providers here. So they literally support loads in memory, SQLite, SQL Server, MySQL, probably got Postgres in there as well. There's pretty much everything that you could need to be supported. So you can change the backend database without changing all of your code that actually runs and accesses a database. So it's like a layer on top of your database coding. So it handles all things like your database keys, organizing it, making things efficient, deleting stuff, migrating databases. So it's really powerful. We'll just start with the basics first, and this is just to get you the tools installed and so you know what you're doing. So there's two things you really need to do. One will be kind of tools on the system. So, installed on Windows or Linux or Mac, tools to handle generating code and using Entity Framework. And they are, if we scroll down somewhere, they are here. So this bit, .NET tool install, we can run this anywhere. So if we just run a command window and we just run it anywhere and we paste that in, this is going to install the tools on this machine. And you can see I've already got them installed. I already use it for multiple projects. But this will install .NET Entity Framework tools. So we can do things like .NET Entity Framework, and then you can see there's Entity Framework installed and it gives you some info about what you can do. So this is for things like doing migrations of databases mainly. When you're working with migrations, which is the ability to, say, change, say this blog class here, where it might have an URL, and you've got the existing database, and you then want to add something else to it, so a second URL or another property or anything you like, normally you'd have to figure out how you're going to edit the database and then migrate any data that changes. So Entity Framework does this all for you if you use migrations. So we'll talk about this a lot more as we actually do it. You want to install this, though, in your actual project. So not just anywhere. This will actually be added to your .NET solution to enable migrations. And before we do that, we actually need to install Entity Framework itself into the project. So if we jump into here, go into Batch Process and Manage Packages, we need to have Entity Framework, and if you search, you'll see Microsoft Entity Framework Core. Install this into this project. This will give you all of the Entity Framework code that you need. And then one more thing you'll need is Entity Framework Core.SQLite we're going to use. So you want to install Microsoft Entity Framework Core.SQLite. And this is because that's the database we're going to use. If you wanted to use MySQL, you'd install Entity Framework Core.MySQL, for example. So you'd install a different package. Or if you wanted the full SQL server, you could install Entity Framework Core.SQL Server. But because SQLite is supported on every single platform, this is why we kind of choose this. So we want Microsoft.Entity Framework Core.SQLite. Install those two. We now have everything we need in this project for using Entity Framework Core. We don't have migrations though, so we don't need to install this package here yet. But considering we will be doing migrations, I'm going to install it now anyway at the same time. So inside of the packages, we are going to search for that exact package. So the design is specifically for migrations. And then with these installed, because the application launch point is going to be the desktop, this desktop is going to also need all those packages. So we're going to have to install, I don't think it'll need design. but it's going to need definitely the Microsoft Entity Framework Core and the SQLite as well. So go ahead and install those into the other project. The very first step in the Entity Framework is to start adding data models. So we have view models, and these are specific to visuals and views. And as much as you will want to use this view model for your database model, it's really not recommended. So on the view model, we have like observable properties, callbacks. We have these view model bases which manipulate the classes. So we don't want those kind of things on a database model. And secondly, once we start doing databases, similar to view models, we're going to do the exact same thing, but on the data models. So we're going to be adding attributes. We're going to be injecting certain settings, saying that a certain ID wants auto-generated keys. There's so many reasons that you want to split them, even though most of your data models are going to look almost identical to your view models. Just try and resist the urge to merge them. So we have a folder called data at the moment. I'm not sure why I called it data. It's not really data. These are just general classes, I guess. There's not really much name for these, but these aren't data models. These aren't going to end up, well, they might end up in the database, to be honest. But they're not strictly data models. So I'll chuck it in here for now, but we'll probably end up moving things that aren't directly database classes somewhere else. So inside of here, let's just add one called settings data model. And let's try and keep the convention similar. So we've got settings page view model, and this is settings data model. So ignore the page because it's a page, ignore the view model, and we'll call it settings data model. We know we need to store this exact same thing, so location paths, we want to store them in the database. So what we'll do is a public string location paths, and it wants to be a list of strings. And again, the way you have to think of databases is they are always rows. They're always tables, basically like an Excel sheet. So if we opened Excel, you can think of almost like this as a database. So you'll have tables. This would be one table. So this sheet would be a table in a database. You'd have things like ID, location paths here to store them all in one. This could be like ID1, and location paths would be a collection of some paths like this. You can have more properties. So as you add another property here, let's say first we need the public string ID. And then say we wanted another setting, which I do believe we have. We have like the vault path. So say you wanted something like a public string vault path, like that. You can imagine the database behind would have another item here called vault path. Now in settings, typically databases have multiple rows. So you'd have things like your print actions here would probably be a single table, and every row in the table would be, this is on row 1, this is on row 2, this is on row 3, and all these properties are inside this table. For settings, because there is no way of doing anything but tables really in databases, there's only ever going to be one settings. So we're just going to have one entry realistically with an ID of 1, and then all of the settings in a single line. So the settings side of the database storage is a little bit more on the flat side. It's not really going to be database tables per settings. So the other option you could have is a table called, settings location paths. And in there you'd have something like ID location path, and then you'd have ID 1, 2, 3. You'd have like path 1, path 2, path 3. But then you're going to have a table just for location paths. Then you'd have a table just for vault paths and things like this. So you want to structure it in a way that makes sense to you. Luckily, it kind of gets taken care of in Entity Framework anyway. Naturally, as you just start writing this code, you'll see how easy it is, and you don't really have to think about the database and what's happening in the background too much. You can just write your models that match your view models, and then save them, and the magic happens for you. So we have a settings data model. You can think of every data model as a table in a database. Now we need the actual database itself. So I'm just going to dump it all in data for now until it grows. And in Entity Framework, they are called database contexts. And a single context is typically access to a single database. So we'll normally only ever have one in our application. And we'll just call this our, and what can we call it? Because you don't want to call it DB context because it's already a context. So I'm just going to call it application DB context. In here, this wants to override DB context, and this is an entity framework construct here. And now inside of that, we will have the override of onConfiguring. And this is what happens, you think of it when it wants to connect to a database. So in here is how we tell it wants to access a database. So it pre-filled it out for us. We have options builder, which is passed in. And this is where we can then do an extension and typically access whichever. So you could have all of these options. We have use SQLite because we've installed the NuGet package. If you installed another database, you'd have a different helper here. We've got a data source. Now we can make it in file, and this will now be a file local to, it will be this desktop, the thing, wherever you launch it from. It would be, say, open in Explorer. It would be part of this folder here, so where the exe is of the application. So right here, we should end up, when it works, with a database called settings.db. You can store this anywhere you like. I'm personally just going to leave it in the actual applications folder for now. So the default is fine. So think of this like configuring your connection string to the database in a conventional manner. And then this database now needs to know about the tables. So the settings data model, for example. So the way we add tables is to just give them public properties, but they are going to be a property of type dbSet. So a dbSet is a table in a database. You can think of it that way. It's not directly related, but you might as well think of it that way. If we do a dbSet of settings data model and call it settings, this is now effectively almost like a list of data models. So you're going to have a table in the form of this dbSet, and you can have multiple entries in here. So almost think of this like a list of settings. But when you do a dbSet, it will make a table in the database. And that's literally all we need now. We have entity framework. This will create a database for us, and we have values here. So now we can consume this and see how it works. We just go into the app for now, and just go to the very top of here and just chuck some sample code in. So the way we want to access the database, so think you want to connect to the database now. We want to do using, because we want to dispose of it and close the database connection when we're done. Using var db equals new, and we'll just spin up an application database context. So by doing new now, this is going to spin up a connection to the database. It's going to call into here. It's going to try and configure and connect to the database using this value. And if that works, we are good to then do things. So the first thing we can do is let's add a row to the database. And to do that, you just access this database set. And you can just do add. And as simple as that, we can now pass in a new data model. Inside here, we will add then location paths as new. Oh, I don't think you do that. You just do an array, a collection. We'll do path 1, path 2, path 3. And that will add to the database. Now, the important thing with Entity Framework is this doesn't happen live. You do this right now, and this doesn't go commit into your database. What happens is Entity Framework keeps hold of all of your values stored in this database, and it figures out what's going on as you're going. So if you did say db.settings.remove, and then you wanted to remove, say, this exact thing you just added, so var setting equals this, add setting, remove setting, then it won't bother hitting up the database. At the point at which you want to commit your changes to the database, you simply do database.savechanges or save changes async, depending on which one you're in. And this would commit at this point. It would figure out what's changed in this database and form SQL strings ready to commit the changes. So it will realize that you've added something and then removed it again. And the ultimate result is to do nothing. So when you come to save changes and hit the database, nothing happens. Whereas if you remove and do add and save changes, it knows that this is actually meant to be added, and it will add and save to the database. So we should be able to get up here, and there's going to be a problem that you'll see in a moment where there is no database. So let's just run this first, and you can see there now. We're unable to track the entity of type that because the primary key ID is null. So there's multiple issues. First, we haven't got an ID set, and databases need to keep track of unique things by ID. So So let's just give this ID a GUID.new GUID for now. And that will solve that problem. So you can see it's already telling you what you need to do. What's wrong with that? ToString. There we go. And it's letting us know that obviously this data model couldn't be tracked correctly because the ID doesn't exist yet. And now the next thing is there's no such table. So you can see it's managed to spin up SQLite, but it's saying the table settings doesn't exist yet. And that's because we need to use the Entity Framework tools to spin up a new database, or we need to use it in code. So one way you can do it is in the source of the project, so the solution. You can run a command, and if we remember from these tools, we have these Entity Framework database tools. So we could do .NET Entity Framework database, and if you're not sure, just press enter, and it will give you the option to say -h for help, and you can see commands are drop and update, and it updates to a specific migration. Well, we don't currently have migrations, so let's just see what happens if you type in .NET Entity Framework database update. You can see no project was found. We've got to go into the batch process 3. Do that again. It's going to build your project. So it's actually building this project in the background, and you can see it says no migrations are found. So the problem is we can't create the database until we have what is classed as a migration that tells Entity Framework how to create that database. And that's done using this tool and command line. You have to use the tool and command line. So if you make sure you're in the batch process 3 folder, and this is the command we need to run. So we want to the .NET Entity Framework migrations add, and then they typically just call it initial create. And you'll see what this does when we run it. So we'll do Entity Framework migrations, add, and then we'll just call ours initial and press enter. So this is going to build the project again. It says it's done. So what has it done? If we go back to our solution, you can see it's made a folder called migrations. And this is auto-generated code, so you don't really need to edit this. You can see the first thing it does is take a snapshot of all of the data about the settings data view model and the application database. You can see it knows about the settings data model. It knows it has a property called string of type text, location paths with type text, the key as ID. It's automatically picked that up, by the way. We haven't even told it it's a key. But Entity Framework presumes certain things, like if you label something ID, it will literally get picked up as the ID in the database. And then we have this initial, which is the migration, and this tells it what to do. So when we run migration upgrade, it runs the up, and this is the SQL commands that are needed to generate the table, or all the tables, or upgrade from the previous migration to the next one. So don't worry too much about this for now. This is all auto-generated code. But you want to run this every time you make a change to anything related to database. So say we created this database now, and then we went into here and added another string and called this, new value. We would then have to run the migrations add to generate the changes. So don't worry about that yet. That's just a hint of what you have to do. Now we've run the migrations, we can either do .NET EF database update, or is it upgrade? Can't remember. Yep, it's that one. And now you can see it reckons it's all done. And it's picked up on this migration, so it's applied that. What that should have now done is if we go into the desktop, bin, debug, the build folder, we should see that database now. There we go. So we have this settings.db file now. And if we want to look at that, let's open up Visual Studio Code, go to extensions, type in SQLite, and in the extensions, we want, this one here is the one most people use. It's by Alex CVZZ. Install this. And now we can just use Visual Studio Code to access the database. So press Ctrl, Shift, and P for the palette. And you can type SQLite. And then we've got these options. So let's open database, choose from file. We want this folder. And we want the settings.db. This now opens up down here in SQLite Explorer. And you can see in here, the database now has a table called settings. It's got all the migration information in, and it's got the ID and location paths that match our model. Now, instead of having to run that command line tool and that won't be any good in deployment when consumers just run your application and it crashes because the database doesn't exist. Instead, in code, after you've created the DB context, you can do db.database.migrate, and that does the exact same thing as running that migrate. So this will just run every time the application starts and apply all the latest migrations to keep the database up to date. So by doing this here and deleting the database and running again, this would re-add the database for us, so you don't need to have it existing. And of course, Rider is a bit too smart somewhere, and it's applied the migrations for us and created the database when we've opened Rider. If we run it anyway, you'll see that this migrate will just run over and not crash because it's going to attempt to do the migration anyway. But this would typically create the database. Now, if we do settings and add, if we go to Visual Studio Code, and I think we'll be able to open this database and keep it open. I don't think it's going to give us any errors. So we open the database, go to here, settings, and play. Oh, you can see it's adding paths. I think the code's running somewhere without us realizing. I think I must have already ran the code. So you can see the values have already been added and committed, but we haven't yet saved this third one. So if we step over save changes and run this again, you can see there's the third one. So that's from the one we just ran. In the same way as saving to the database, it's just as easy to get back. Just do db.settings saying, let's just do to list. Let's just get everything back from the entire database table. You wouldn't typically do this, but we just save our all entries or all settings. And this isn't just, all settings. This is a duplicate. We wouldn't normally have multiple settings. But if we do that and run here, you'll see every time we're running the application, we're going to get an extra entry added for now. That's just how the code's written. And now this all settings, you can see there's now 5 entries. And this will persist between changes because we keep writing this to a database. That's how we fetch from the database that easy. To delete from the database, again, very similar. We now have all of the items here. So we could just say, loop through them all and delete them. So you could just say for each var setting in, and you could just do settings. You could enumerate over the database. And then you could do db.settings.remove and remove the setting. Doesn't like that because it's got the same name. So that will then remove all entries. And then just bear in mind, if you don't call save changes, nothing happens. You don't save anything. So at the point at which you call save changes is when you hit the database up and do something. So we can see if we add it again here, put a breakpoint before we run, the code will have ran all the way to here. We've removed it in Entity Framework here. But if we run the code here, you can see we have a single entry. We haven't actually removed it yet. And when we run save changes and run again, you can now see it's gone from the database. And I realize why this has been auto running and generating code as well. It's because we're in on framework initialized. So Rider actually runs this code in design time. So when this is getting built in the background, this page, it's been running this code. That's why we keep getting sporadic database changes and additions. So we move this out of this code and ran it somewhere else, it wouldn't be doing that auto-generate thing. Let's do it on go to actions, say. So when we navigate to the actions page, we'll run the sample code. So now in here is a safe place to run it. Let's just go through this once more so we know what's going on. I'll close down Visual Studio Code. I think we'll have to close down Rider. We'll delete this database as if it doesn't exist yet. Restart Rider, and this shouldn't run this code. So yeah, it hasn't created the database this time. It's not there. Let's compile. That's compiled fine. Still not run the code. If we now run the actual program, we're now up and running. Still no database, which is good. And now if we navigate to actions, we hit the breakpoint, we create the context. We still shouldn't have the database, which we don't. When you apply migration, you can see it's going to throw. So ignore this throw. This is actually caught. So throw exception for RC just bubbles up and it doesn't end up at the top. This is how it checks if the file exists. And if it doesn't, it's going to create it for us. So just press F5, step over, and it should carry on. So you can see the migrate now is going to check if it exists, which it doesn't, and it's going to create it. And then you can see once we step fully over the code, we tab in and refresh, there's our database. So what we can do is just leave this migrating code if we liked, and every time we wanted to fire up the application in the first place, you'd call this kind of migrate. We'll cover that a lot more in future, but that's how that bit works. We just open the database at the minute. You can see settings has nothing in. And if we step over this, creating the new setting, and refresh, you can see it doesn't commit to database. There's nothing here. The same as here, it doesn't create it. So there is no database entry. But when we call save changes, this then has just run the SQL command for us. And if we refresh now, it's hit the database. So it's just important to remember the save changes is the point at which the database is actually committed to. This will then pull it out. So as we enumerate over this, this is going to hit up the database at this time and read the settings, which we now have that one, which matches what we're expected. And you can see it's also put it into the correct format and split it out for us. So even though the database has stored it as a string, just as what looks like a JSON string ultimately, it's deserialized it into our class for us automatically. And then in this instance, we're going to remove, and just like before, they've been removed from this in-memory entity framework object. But until we commit a save, it would exist in the database until that point, and now it's gone. And if we hover over settings, you can see it's now empty. So it stays all in memory, but gets flagged as needs removing. And then when you commit the changes, it does all of the updates for us. So it's a very powerful tool, and there's a real lot to cover here to fully understand Entity Framework. You're not going to understand it in one go, but this is a nice little overview of getting started. We have the context, which you can think of as database. We have the migrate, which makes sure the database structure is always correct and created. Then we can create these data models, which are entries inside of tables in the database. And we manipulate them however we want, adding them and saving, fetching them or deleting them. And that's really most of how it works. I will cut this out of here for now. Or shall I just comment it out? I'll comment it out until we move on. So we've still got this code, but we don't want this code just running when we run the application at the minute. Now we've done that, we'll look at actually saving all the properties correctly and loading them up.